Hello everyone, welcome to solve this math Olympiad algebraic problem, and here we have 3 to the power of n minus 2 to the power of n equals to 65, and we have our n belongs to z. It means that our n must be an integer. So the very first step we are going to do is here first we multiply and divide the exponents of both of these terms by 2, and it will becomes 3 to the power of n and its whole power 2 by 2 minus 2 to the power of n and its whole power 2 by 2 equals to 65. And now in the next step, we use here the exponential line. We multiply this 1 over 2 by n and we obtain 3 to the power of n by 2 and its whole square minus 2 to the power of n by 2 and its whole square equals to 65. So now we convert this nice exponential equation into the algebraic form, so that here we take some substitution and we first take x equals to 3 to the power of n over 2 and we take y equals to 2 to the power of n over 2. So when we take these two substitutions in the above equation, so our above exponential equation becomes in algebraic form and it will be written as x square minus y square equals to 65. So here we use the nice square identity and we know that x square minus y square equals to x minus y times of x plus y equals to 65. So you see here we in the left hand side we have two factors. These are multiplied by each other. So now here we make the two factors of 65, and now first we make the relation between these two factors, and we know that x minus y is always less than x plus y. So now we make those factor of 65 which satisfy this condition. So first we find the factors or pairs in which we get 65, and these pairs are 1 times of 65 is 65, and 65 times of 1 is also 65, and 5 times of 13 is 65, and 13 times of 5 is also 65. So now we compare all these pair with this relation. So here we have our 1 is less than 65, it satisfies this condition, so we choose this case. And here you see that 65 is greater than 1, so we rejected this case because our first factor is always less than the second factor. So here we have 5 is less than 13, so we choose this pair, and 13 is greater than 5, so we rejected this pair. So we have two cases. The case number 1 is this and case number 2 is this. So now first we write here our case number 1 and we find the values of m from case number 1. So now we compare the left hand side with 1 and 65. So you get here x minus y equals to 1 and x plus y equals to 65. So now first we solve this case and we find the value of x and y first, and after that we find the value of n. So here we named this as equation number 1 and this as equation number 2. So here first we add equation number 1 and equation number 2. So when you add these two equations, then you see here this is negative and positive y are cancelled by each other, and we get x plus x is 2x and 1 plus 65 is 66. So in this case you get the value of x is 33. And in the parallel we subtract equation number 1 and equation number 2. So when you subtract these two equations, then you change these signs. So here you have this x are cancelled by each other and we get minus y, and minus 2y is minus 2y, and 1 minus 65 is minus 64, and you easily get the value of y is 32. So we have these two values of x and y, and now we back substitute the values of x and y, and you see here we have x is 3 to the power of n over 2 and y is 2 to the power of n over 2. So we substitute these two values here and you get the value of n. So we have 3 to the power of n over 2 is 33, and 2 to the power of n over 2 is also 32. But in this case you see here in the start of the problem, we have a condition. We just find the integer solutions of this problem. So we need only integer solutions, but in this case you get the real solution. So that we rejected this case because we need only integer solutions. So we proceed here this case only, and in this case we write 32 as 2 to the power of 5, and we have 2 to the power of n over 2. And now we compare both of the sides and we equate the exponents, and we get n over 2 equals to 5 and n equals to 2 5s are 10. So this is the our first integer solutions of this problem. And in order to find the other integer solutions, we need to solve case number 2. So in case number 2, we compare the left hand side with this pair. So we have over x minus y equals to 5 and x plus y equals to 13. So this is our case number 2. We will write over case number 2 here. So in case number 2, we have x minus y equals to 5 and x plus y equals to 13. So we call this as equation number 3 and we call this as equation number 4. And now we solve these two equations and we get the value of x and y first, and after that we get the value of n. So here first we add equation number 3 and equation number 4. And when you add these two equations, then you see here these y are cancelled by each other and we get x plus x is 2x equals to 5 plus 13 is 18, and we get the value of x equals to 9. And in the parallel case, we subtract equation number 3 and equation number 4. And when you subtract these two equations, then you change the signs and we cancel this x and we get minus y, and minus y is minus 2y, and 5 minus 13 equals to minus 8. So here we get the value of y equals to 4. And now we back substitute the values of x and y, and we know that the value of x is 3 to the power of n over 2 and the value of y is 2 to the power of n over 2. So we put these two values of x and y here and we get 3 to the power of n over 2 equals to 9, and the value of y is 2 to the power of n over 2 equals to 4. So in this case, we write this 9 as 3 square, and in the left hand side we have 3 to the power of n over 2. And now we compare both of the sides because bases are same, so we create its exponents and we get n over 2 equals to 2. So in this case we get the value of n equals to 4. And now we solve this case, and in this case we have 2 to the power of n over 2 equals to 4 and we write it as 2 square. And now we compare both of the sides and we equate its exponents, and it will becomes n over 2 equals to 2 and we get n equals to 4. So in this question we have two integer solutions. So our first integer solution is 10 and the second integer solution is 4. So these are the two solutions of the given question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.